The future of Victorian infrastructure is green. Recycling Victoria has laid out a 10-year roadmap to a circular economy, a future where our state's public and private sectors will unite to prioritise sustainability. At the core of this are our public assets, the roads and railroads that connect us and ignite possibilities. But where does the change to green thinking begin? The Recycled First policy. Recycled First will require transport infrastructure projects to optimise the use of Victorian crushed brick, crumb rubber and reclaimed asphalt pavement take precedence over virgin materials. For information, technical advice and support on bringing your sustainable project innovations to life, drop EcoLogic a line. Recycled First, supporting purposely greener infrastructure.
Thank you, everyone, and good morning. Welcome to our showcase. So let me just pop through and get cracking on this. So thanks for dialing in this morning. My name's Doy Lee. I'm the industry manager of EcoLogic, and I'll be your host for today. And co-piloting in the co-host seat is our industry support officer, Lauren Rowett. So before we get started, I do want to acknowledge, although some of us are dialing in, most of us are dialing in virtually to this event, that we still meet on traditional lands. So for me, sitting here in Melbourne, I'd like to acknowledge the people, the Wurundjeri people, the Kulin Nations, and that we pay our respects to the elders past, present, as well as any First Nations people we might have in the audience here today. So welcome to our Innovation Showcase. This is very much all about showcasing the very best that industry has to offer at the moment when it comes to greener recycled materials for transport infrastructure. This is a collaborative initiative, and in the audience, as most of you will know, we do have representatives from not just the big build projects that you see there, but from across local, state government, as well as we've got people coming in from other jurisdictions as well. So I think when I checked this morning, we had over 200 people registered to dial in this event. So we want to thank you for coming along. And for those who miss it, we'll record this. It'll be uploaded on our EcoLogic knowledge share on YouTube, and we'll also share the presentation slides so that you can, hopefully we've inspired you to reach out and connect with some of our presenters here today. So for those who haven't heard of EcoLogic before, we're a Victorian government initiative to really deliver, one, the Recycle First policy, but secondly, help transition Victoria towards a circular economy. So what that means is optimizing circular materials usage. We have a technical team that's doing a lot of work with asset owners, with the Department of Transport and Planning, with our rail operators to look at trials and validating new materials and updating standards and specs. Myself and Lauren, we work in the market development space, so it's very much about building supplier capability, and the showcase is just one way that we do that. And we deliver a lot of awareness and education, and we have a strong comms component to our team. And so there's masterclasses, lunch and learns you can get stuck into, reference guides and materials that we've published both on our website and in our knowledge hub for you to learn more about recycled materials. And helping me today on the showcase event is our expert panelists. So our panelists are here to hear the presentations, ask questions, and give some advice and direction to our presenters. I might kick off today with introducing Arthur. Arthur, did you want to say hello from Department of Transport and Planning, and perhaps, what you're hoping to get out of today, and a little bit about yourself? Arthur.
Yeah, thanks, Doy. Yeah, no, so as Doy said, I'm Arthur Apostopoulos. Work in the Department of Transport and Planning, and my team is responsible for all the road engineering specifications and technical documents, and we work closely with other government departments as well as industry associations. So looking forward to being part of this discussion, Doy.
Thank you, Arthur. Irina, representing Major Roads.
Hi, and thank you, Doy. My role is Deputy Director of Engineering at MRPV. So me and my team, I guess, or engineering team widely, support MRPV projects from a technical and engineering management point of view. And the interest is to kind of promote the use of recycled materials and low carbon emission materials. So we're here to support, and remove any barriers, I guess, from either technical standards or industry or kind of implementation point of view.
Brilliant. Thanks, Irina. And last but certainly not least, representing the rail perspective, Kerry.
Thanks, Dewey. My name is Kerry Gugusas. I'm the Manager of Innovation and Continuous Improvement at Rail Projects Victoria. My team basically helps to enable innovation, share ideas, and build a culture across our organisation. We're very interested in driving excellent sustainability outcomes on our projects. So therefore, I'd love to hear what people have to pitch and what we can do to support and get things into action.
Fantastic. Thank you, Kerry. So as you can see, very much a collaborative approach. I just want to, I said earlier that this is very much, these events are very much a call to action, because out there in the audience, you're working on live projects. There's opportunities to really push innovation, drive the uptake of these materials beyond compliance, as well as making them business as usual. So if whether you're working, you're an asset owner, or you're working with design, engineering, construction, the EcoLogic here is very much about leveraging the big build opportunity and projects, and also your projects to see circular outcomes for Victorian industry. So I just want to go through a bit of a quick whirlwind tour of previous showcase participants. So about 2 years ago, when we kicked off this series of events, we had a social enterprise called OC Connections come and put forward the idea of collecting old road bollards to convert them back into new ones. So they launched at the end of last year. That's now available, so you can go onto their website, and we're happy to see that these bollards are starting to be rolled out across the big build, as well as Melbourne Airport and some other areas as well. Through the series, we've worked with the Plastics Industry Pipe Association, and we brought recycled plastic conduit pipes into the market here in Victoria. So that's also available for projects that are working in the space. Vinidec's one of the manufacturers for these plastic pipes. And we've also seen innovations such as Orca Civil's polymer concrete with recycled glass being used on the St Kilda Road laneway project. As the lane separators for the bike lanes there. So again, a showcase participant that's sort of seeing that uptake. I also want to take this opportunity to probably remind, or if you haven't seen these before, plenty of innovations that we're hoping to see adopted by the big build and your projects. The University of New South Wales Smart Centre have developed a great product called the Green Ceramic. So this is a ceramic that is made from textiles and recycled glass. It meets Australian building standards, so that's available. We've had Porous Lane. So this is a company that takes end-of-life tyres and creates a permeable pavement can be used in car parks and others. I think some of the local councils have trialled it. One of our projects is looking at adopting that. So from a flash flooding and heat mitigation perspective, great product. We've got Casafico, who actually take polystyrene and other construction waste to make a leveling coat. So it's not a shotcrete. You can see it's a very lightweight product that can be used to render and smooth out surfaces. And they also use that same product mix to create building blocks, which are much significantly lighter than traditional building blocks. And obviously come with not just the green credentials, but the safety ones as well when it comes to lightweight building materials. Sometimes the innovations are very simple. This one's been around since World War II here in Victoria. The Dura panel made by Ortec is made from compressed straw. So this can be used as in acoustic panels and building panels. And it was actually used in the Sydney Olympics with the Commonwealth Games coming around soon. I'd love to see this and other similar innovations adopted again here in Victoria. And just last year, we had Entire come along with their carbon char product. So this is an asphalt additive. And we're looking to trial this as a hydrated lime replacement. So we're expecting to see improved rutting and increased lifespan of the asphalt. So this is a product that's coming to Victoria. I think Alex Fraser at the moment are looking at working on a trial to deliver this. And so if you're out there, there's a lot of asphalt being poured on our projects. Great opportunity to use this and trial this as well. So now I'll move into, it's 10:40 sharp, so I'll kick off the main event. We'll have 4 presentations today from the industry. The audience, you'll know that obviously you can't, you'll be able to, although you don't have video functionality, you can ask questions of our presenters in the chat function. So if you have any questions for our 4 presenters, pop it in the chat function. Just make sure you direct it to the person so they know who you're asking the questions of, and our presenters can jump into the chat function and answer any questions. So 10 minutes to pitch, 10 minutes to field questions from our panelists. Without further delay, I will move straight into KiStrategies. I think I've got Andrew. Over to you. Tell us about KiStrategies and Ambiolock.
Right, thank you, Doi. Appreciate the invitation to showcase our technology, and good morning to everybody. Just a little bit of background. KiStrategies is a company that Grant, Scott, and myself founded roughly a decade ago, and it was really addressing an issue we identified in the industry, and Grant and I are both engineers, although Grant's also a scientist and has a degree in law, so he's a little bit of an underachiever. And the current chair of the Chemical College at Engineers Australia. But we identified an issue in the environmental contaminated land sector where there was really no solution for this emerging contaminant of concern, which is abbreviated PFAS. It's a family of thousands of chemicals that are extremely persistent. They don't biodegrade, they're shown to bioaccumulate, some are suspected to be carcinogens. And as the industry has been phasing out the use of these particular contaminants, solutions for remediating them and dealing with them, particularly with respect to building materials like concrete, asphalt, and other solids, just weren't available, weren't being developed. And that's really what led us to develop the Ambiolock technology. So next slide, please, Joy. So what Ambiolock is essentially a physical, not a chemical solution to being able to bind and encapsulate these PFAS contaminated solids, whether they're recycled concretes, asphalts, sands, gravels, anything that can be used to create new structural materials, whether it's a pavement or a sub-base material. And it's very effective at binding the PFAS to such a degree that it physically cannot leach out of that matrix. It's not a one-size-fits-all solution in that there's no standard dosing. Unfortunately, it does vary from project to project because what we find is the concentrations of PFAS from site to site do vary, and also the distribution of types of PFAS compounds. They're a long chain, they're a shorter chain, and they have different properties. So there is some front-end bench scale testing required, which optimizes the dosing required, the performance of the solution, and has an impact obviously on the cost of the solution as well. But we have been able to successfully create sub-base materials that are many megapascals in strength. I think we had stabilized sand at close to 40 megapascals. Our 32 megapascal concrete mix has achieved results greater than 40 megapascals and extremely low permeability and water penetration results, which I'll talk about in a minute. Next slide, please, Joy. And it's a product designed to really meet this industry challenge of waste avoidance, reuse, recycling. It's something we've spoken about for decades, but industry has unfortunately been a little slow to move down that road, particularly with contaminated materials, and there's been far too many of these being shipped to landfill, often transported across multiple states in Australia for treatment and then subsequent landfill, when these materials could be cost effectively, environmentally incorporated into useful products or structures and other solutions that provide the community with significant benefit. KiStrategies also partners with Fire and Test Australasia. It's a company that has a wealth of experience managing challenging projects and interact with sites that have PFAS contamination associated with this historical use of aqueous firefighting foams, which we know have contained PFAS in the past for many decades. They are also Supply Nation registered and Inaway accredited. And we're proud to partner with a company like Fire and Test Australasia and provide not only great environmental benefits with the product, but also great social benefits. Next slide, please, John. So one of the things we've been able to achieve is reducing the carbon footprint associated with using concrete as an encapsulation or stabilizing agent. And we know that the cement industry is one of the largest emitters of CO2 globally. Ambiolock, when used in a concrete or a stabilized sub-base material, is able to significantly reduce the amount of Portland cement required or equivalent binder, and also through the use of recycled aggregates, reduce the footprint even further, as opposed to having to import virgin aggregates from offsite. And we believe that a saving of around 20% in CO2 is achievable, possibly higher with stabilized sand and other materials where cement replacement can be greater. We think for every 1,000 cubic meters of concrete using Ambiolock, the savings, roughly 82 tons or thereabouts is the estimate. Next slide, please, John. So essentially, there's no limits to what Ambiolock can be used for. Any product that requires cement, concrete, and similar cementitious matrices to construct, be it roads, pavements, all types of structures, it essentially can be used anywhere where concrete is currently used. So the range of potential reuse and recycling options is extremely large. Next slide, please, John. So this slide just presents a very quick overview of testing of some material from an airport in Queensland. It wasn't material that we would typically consider very suitable for constructing concrete. It was a loamy sand with some organics, had low to moderate levels of PFAS, fairly large quantities of it present, representing a large environmental liability, leaching PFAS to the environment, also huge cost to send this to landfill. So we did some laboratory scale testing to see what could be achieved, creating a large number of monoliths and putting those monoliths through a range of different tests to look at compressive strength, permeability, and the amount of PFAS that was leaching following treatment. Next slide, please, Dwayne. And we were able to achieve significant reductions in permeability. The graph in the top right shows leaching of PFAS in particular, which is the most abundant fraction of PFAS that was present. And you can see initially the concentrations leaching were well above the guideline level we were trying to achieve, but within the space of a week, we had those leachable fractions down to the point where they were barely detectable, and beyond that, not detectable for a whole year of testing. So we were able to bind more than 99% of that PFAS into that stabilized sand matrix. Graphs on the bottom, figure 2, shows significant reduction in the coefficient of permeability that was achieved relative to regular stabilized sand using the same materials at the same dosing, but not including Ambiolock, and the level of reduction in water penetration that was achieved. Next slide, please. And then to test the durability of the stabilizing solution, we destroyed those monoliths, ground them down, separated them into various particle size fractions, and then had a look at how much PFAS would leach from each fraction. And, excuse me, but as you'll note from the graph, that for most of the fractions, PFAS was not even detectable after degradation and destruction of the cores following treatment.
Just a minute to go, Andrew.
So just to summarize, sorry, just scratching through. Look, I think in a nutshell, there's a lot of considerations to be made when it comes to various projects, but for a small project, we find the cost benefit relative to sending material to landfill is at least break even, but for large projects, we see savings of in excess of 50% of what landfill disposal would cost to utilize those materials on site, sometimes well greater than 50%, whilst also providing a very effective environmental solution with other social benefits, along with the partnerships that KiStrategies has. Next slide, please. So this is the final slide. Just in summary, It's a solution that's not limited to PFAS, although that's been our focus because it's an area where there's been significant industry need. It is viable for other contaminants as well, and also works extremely well with concretes that have rapid set additives and cure in 24 hours or shorter. So with no loss of effectiveness in terms of the leaching reduction.
Fantastic.
So we'll leave it there.
Thank you, Andrew. And I've got my first hand up from Kerry. Kerry, question.
Andrew, thank you so much for taking us through that. I saw, so just to confirm, you treat the recycled material on site, so there's no transportation back to a factory or anything. So my question was around, so what sort of volumes can you process in a day, and how long does it typically take? Like, is it pretty instant, or like, say you want to treat 100 cubic meters of contaminated soil? How long would that sort of take?
Yeah, Kerry, good question. So look, the treatment's not particularly time consuming if the materials are ready to be incorporated into the matrix. So if you've got concrete that's already crushed and it's crushed to suitable size specifications, or you have sands and gravels, etc., really the time consuming part from our perspective is doing the upfront testing to work out what level of dosing is required and what performance. So essentially developing a recipe in terms of the proportion of aggregate versus the proportion of cement and Ambiolock. And that's a process that typically takes a number of weeks to complete, but it's worth doing because if we can reduce the amount of dosing, for example, the Queensland pilot test we did, we could reduce the dosing by 50%, which was a huge cost saving for the project in terms of the amount of product required, etc. So we look at ways to minimize that whilst achieving the best environmental outcome. But in terms of on-site implementation, the timeframes increase where there's more preparation work required. So if you haven't pre-crushed concrete and there is crushing and screening required, then that needs to be factored in. But other than that, the Ambiolock goes in at the time of concrete batching. So it's essentially as quick as you can make the concrete, we can add the Ambiolock.
Thanks, Andrew.
Thanks, Kerry. I think, Arthur, you did have your hand up next. So, Arthur.
Thanks, Doy. Yeah, thanks, Andrew. Just curious to know, in terms of the Environmental Protection Authority, how do they go about categorising the material once it's been treated? Is it still defined as a hazardous waste material? Because one of the issues we have in terms of the use of recycled product is that issue as to how it is categorised, but also the recyclability of it at the end of its life. So if we've got it in concrete or asphalt, and at the end of its design life, it needs to be crushed or ripped up and reheated. Just wondering what the end of life issues are.
Look, it's an excellent question, Arthur, and it's not something we have a formal classification from EPA in relation to. EPA is extremely supportive to the concept of the reuse and the retention of these materials on site. They've long said that they don't want these materials going to landfill, which is currently what's been happening. But the testing from the Gold Coast material indicated that at the end of the predicted life of that material, after crushing and reusing, that material wouldn't be classified as PFAS contaminated waste based on the concentrations that we measured after treatment. So it's quite possible this would simply represent regular C&D type waste and be handled accordingly as opposed to a contaminated PFAS waste. But if starting concentrations were significantly higher, which does occur on some facilities, particularly old fire training grounds, that may not be true in all cases, but certainly for low to moderate levels of PFAS, it's very difficult to measure them in the material after treatment. They are very tightly physically bound within the silicate matrix. So our view is those materials could be in the future recycled, reused, or transported elsewhere for similar use with very few restrictions. But that will still need to be discussed with EPA. Thanks, Andrew.
Thanks, Arthur. Irina.
Hi, and thanks for the presentation. It was very, very informative. And I assume you're kind of treating the concrete, crushed concrete, contaminated crushed concrete, but equally you're also having contaminated soil treatments. My question is around the implementation of this in road infrastructure kind of projects where you have kind of, I guess, big volumes of a lot of different materials. Obviously, crushed concrete can be used as a aggregate or as a subgrade as well. But in terms of the economy of scale, I guess, can you tell us what would you say that it works for the project? Because obviously it needs to be attractive to be applied, and is it cost effective if you have larger volumes or smaller volumes? Is that efficiency dependent on how much space you have to treat it on site? Because obviously road projects have limited project areas, and also specific staging, I guess, of work. So maybe you can tell us something about that.
Yeah, look, that's also a good question. Look, space is a factor, certainly, and particularly if materials do need some pre-processing or crushing. If we are just talking about gravels and sands that have some PFAS contamination that can be utilised, say as a stabilised sub-base material with very little pre-treatment, then that issue becomes fairly insignificant. From a cost perspective, if we talk on a per tonne basis, typically we take things to landfill and pay a per tonne fee. PFAS materials tend to range between $300 and say $600 a tonne just for disposal, plus transport and handling. At certain concentrations, those materials can't be disposed and need to be treated first before they can be disposed. And then we start to talk about costs in the $1,000 per tonne and above. What we are talking about in terms of additional Ambiolock cost is around about $60 a tonne over and above the regular cost to produce concrete. However, there is a saving associated with using the recycled materials and not having to purchase new aggregate. So that $60 is somewhat offset. But if there is a disposal requirement in that project where you're saving $300 to $600 a tonne in material disposal costs that you can then incorporate, then it becomes a cost positive solution by not being able to retain all those materials on site, not having to pay landfill fees. So the economics do change from project to project depending on what you're dealing with on the quantities, but certainly the larger the quantity, those economics improve. And where landfill disposal is involved, typically for anything 1,000 tonnes and above, typically it's a cost positive solution.
Sorry, Ariana, you're on mute.
Any limitations in road projects in terms of the space to treat it, or that's not an issue, I guess?
If you have space to create concrete, then that's sufficient space. And obviously, if material needs to be crushed, then some crushing equipment needs to be brought to site, and there needs to be space for that process as well. But the main limitation is this is not a solution aimed at fine-grained, expansive type soils like clays, for example. It is really targeted at solids and coarse soils that are suitable for use as aggregates. So the point is it's aimed at creating products of some degree of structural strength and usefulness.
Thank you.
Fantastic. Andrew, thank you. Very compelling. I think there's some questions that have popped up in the Q&A function. So if you're in the team, feel free to hop into the chat and answer those questions. So I want to thank you again for presenting Ambiolock. So I think it's a great innovation to see, taking some of our most difficult contaminants and potentially making them workable. So thank you.
Thank you.
Don't worry. So coming up next, we have Shane Ramsey from CRDC Global. Shane, the floor is yours.
Thanks, Doi, and thanks, EKOLogic, for the opportunity to present today. So, one of the directors with CRDC Australia, so I'd like to introduce our company, Centre for Regenerative Design and Collaboration. So next slide, thanks, Doi. So a little bit about our motivation. The essence is we have a drive to take the plastic waste problem of the world and upcycle it to actually utilise it in a way that has environmental benefits and also social and economic benefits. So that's our driver. And the way we're doing this, if we just go to our next slide, thanks. is through our lightweight eco-aggregate that we call Resonate. So a couple of key takeaways when you're looking at Resonate is that we accept all types of plastic, so resins 1 through to 7, and we can take that plastic waste stream in a commingled and even in a dirty format. So we were born from a desire to do ocean cleanup. So that's the sort of waste we started with. And we continue to utilize all forms of plastic waste. And we don't just convert it into an aggregate that we hide in construction materials. Resonate is an eco-aggregate with standalone construction credentials. So it has structural credentials, it has thermal values, it has fire rating improvements. Of course, it's lighter to work with, and of course, the incredible environmental benefits. So that's what we're doing, is creating Resonate, our eco-aggregate. And we just have a look at our next slide. Thanks, Billy. So where is our plastic coming from? So just to give you an idea, currently we have a full-scale commercial operation in South America, South Africa, the United States, and we have a pilot plant operations in Europe, Hong Kong, and Southeast Asia. And in the coming months, we'll be commercialized and operational in Melbourne, Victoria. So the waste streams we'll be accepting from the Victorian community will be exactly what we're accepting globally, which is industrial waste. So post-industrial waste, waste that often goes straight to landfill, agricultural waste that often goes straight to landfill. We take all of that. Environmental waste in the middle there. So I mentioned that was a real driver for us as an organisation. Ocean cleanup, river cleanup waste, it's mixed, it's dirty, and it's often not recycled. We take all of that waste, and we'll continue to do that until environmental waste isn't a problem. So that's a driver for us. And domestic waste. We take plastic waste from the domestic market. So in the United States right now, we're running a full-scale project with a full-scale operational plant just outside of New York, where we capture all the waste of one community. And then that waste comes into our plant, is converted to Resonate. That municipality then supports the purchase of Resonate, which goes into their civil projects. So we've created a circular motion there, that the waste becomes part of the community's projects that enrich and appreciate in the community. So yeah, that's a takeaway. We use all waste. What are we doing with it? Well, this slide highlights, I guess, at a scratch what we're doing with it. Concrete masonry units, bricks, blocks, pavers. Last year we did about 1.2 million bricks, blocks and pavers that we've got in real world applications. So those concrete masonry units have anywhere from 5 to 25% aggregate replacement with Resonate. And then of course we've core fill those walls, those applications, with concrete that contains Resonate. So now we have structurally integral walls that have improved thermal values, have improved fire ratings, have a whole range of benefits, not the least is the environmental benefit. Precast concrete, right now we're in some large civil projects in South Africa, pipes, pitch, drains, tilt-ups, and we have all the real-world testing data there. And of course, pour in place concrete, which is something we're engaged in, from structural to non-structural concrete applications. So that's just a snapshot of what we're engaged in. So maybe we'll just have a look at the next slide. Thanks, Louis. So we have spent quite a few years, and we've been rigorously tested Resonate and CRDC as a company. We've mentioned here in this slide ASTM testing, American Standard testing, as an international benchmark, because we are globally rolling out Resonate. But we acknowledge and we appreciate the Australian standards are equally high and stringent, and rightly so. But just the reason we reference them here is because we've done thorough testing for fire, thermal, compressive strength, and we're doing that right here in Australia. So right now we've partnered with Southern Cross University under the Commonwealth Backing Recirculator program. We're building a pilot facility in northern New South Wales, and we're engaged in a 2-year testing regime, which includes all the testing we've done globally, including our LCAs, And then we're running them again here in Australia. So LCAs, leachate, microplastics release. But the takeaway here is once resonate is in the concrete, it's not in there as a volume expander. It actually mechanically and chemically adheres, and it becomes an integral part of the matrix. The appearance stays the same, the workability stays the same, the end use looks exactly the same with all of the benefits that come. Thanks, Doi. Next slide. So some here will sit with a real environmental focus, and others would have the weight of responsibility for construction and structural integrity on their shoulders. And I think everyone here is probably married two motivations together, construction and environment. And as an organisation, as a company, that's key for us. So we've had a focus on our construction credentials, but we are driven by our environmental benefits. And this slide just highlights some of them. The leachate I mentioned, microplastics release, we're thoroughly tested and documented and sailed through those tests. But the key ones, we take all plastic, we divert it from landfill, and we utilise it in a construction commodity that has real value. So that's just an environmental snapshot. We'll have a look at the next one. Thanks, Doi. So this speaks a little bit to us as a company. We were motivated by the plastic tragedy that the world is facing. This house on the screen with the blue house here is one of over 500 social housing projects that we've been directly engaged in with Habitat for Humanity. What we've done is we've taken the community's waste, we've converted it to resonate, and then with Habitat for Humanity, we've built over 500 homes. So the bricks, blocks, pavers, concrete, slabs, footings have resonate in them. Then we've educated the community on how to manage their plastic waste appropriately. Now their plastic waste is becoming their neighbours' homes. And that's something we're really proud of, working with Habitat for Humanity, and just speaks a little to our motivation to create a circularity where we eliminate as much plastic waste from the environment as possible. But then with what we're left with, we try and make something that's of value. We'll have our next slide. Thanks, Doi. So I mentioned the concrete applications, but for some here, the HMA, the asphalt applications would be really interesting. So we've spent several years in full-scale laboratory testings in the United States and South America. Last year, we did real-world applications. This is one of them. 500 tonnes of asphalt was poured on Route 27 upgrade with our construction partner, Global Via. We used between 1% and 3% resonate into this highly trafficked road upgrade. And now, close to 12 months down the track, we got the real-world results supporting all of our laboratory testing data. So that's just something that we thought would be of interest. And just our final slide. I think that's it, actually, Doi. So friends, I guess the point is that we're highlighting is we've got the runs on the board, but we have a real desire to do it here in Australia. And one of the questions from EcoLogic is how can we move this down the road? Well, with our full-scale plant coming online in 2023 in Melbourne, we acknowledge the support that EcoLogic already provides around standards, support with standard specifications, compliance, and standard development in light of recent innovation. So we're looking to continue those relationships and really draw off the experience of the industry. What do they need? How do we comply? And then to go in harmony with that, what I guess we're looking for in Australia is opportunity to walk into real world projects, to actually roll out, resonate in real world testing applications so that we can not blindly say what we think it's going to do, but we can build off our global experience so we know what we're expecting. The companies we work with know what to expect, but we can demonstrate it right here in Australia with Victorian waste in Victorian projects using Victorian construction methods. And that's where we're leaning on you and your organisations to help us. Thanks, Doi.
Not a problem. Thank you, Shane. Over to the panel. Any first takers? Otherwise, I might go alphabetical.
I do, Doi. I've got a few questions.
Oh, Kerry. Kerry, then Irina. Kerry first.
Okay.
Shane, thanks a lot. It's great to see, how one person's rubbish is effectively becoming another person's house. So that's like, you know, an incredible outcome. I have some questions for you in an Australian context. So here in Victoria in particular, we have our Vic Road specifications, our concrete specifications, 610, etc. How does this material, this recycled aggregate, I guess, fit in with that? Has your company done any research to see if that's actually permitted in those specs, or if there's any further you know, technical work that we needed to get that approved across the line?
Yeah.
And also the second question to that as well, it's more about case studies and, you know, structural applications that you've done globally. Have you used this in, like, say, a bridge, for example?
Yeah, thanks, Kerry. Excellent questions and appreciate it. Yeah, with regards to 610, we have reviewed and examined, and obviously the belief is and the understanding is we will comply, but I guess that's leaning back on that question to say, okay, we want to work with the Victorian infrastructure team to make sure that we're ticking all of the boxes that are required. Obviously, as you say, with the global rollout, we've been working with a range of international standards and testing and application requirements. So for now, we're zeroing in on the Victorian ones, and that's where we want to work closely with those who have the knowledge and the understanding to see that with what we've done, that we will comply moving forward. But yeah, the short answer is yes, our belief is yes. And we're happy and looking forward actually to demonstrating that application. In regards to the second part of the question with a bridge construction, for example, the short answer is no, we haven't been engaged in bridge construction. And when you look at the volume of resonate that we're currently processing globally at the moment, so one plant is doing about 30,000 tonnes a year. We have 3 plants currently running. Australia will be online soon. 30,000 tonnes is getting absorbed by volume quite quickly into less integral construction projects. So we're not needing to push it into those highly engineered and structurally specific projects. We're getting used up, for want of a better explanation, we're getting used up in less critical applications in the first instance. We look forward to developing as the need arises into some of those other applications, but the focus hasn't been there in the first instance.
Thanks, Shane. Appreciate that. On to the next panelists.
Thank you.
Thanks, Kerry.
Arena.
To go next. I've got a couple of questions as well. One is about the material you're using, and it's great to hear that you're utilizing absolutely everything that in the waste, and you're going up to 50%, I guess, replacement of the aggregate in kind of concrete. So are you including the soft plastic as well in the material, and how do you control, I guess, the quality of that material at the end, because it can vary, I guess, in terms of the properties, and how can that then compare with the properties in the concrete that you want to achieve and demonstrate that is I guess consistent?
Yeah, thanks, and appreciate that question. Firstly, soft plastics, yes, we know that's high on everybody's sort of list of priorities at the moment. We understand the concern around soft plastics, and absolutely soft plastics are in fact an integral part of our feedstock as we develop resonate. So I guess in essence, we develop our resonate on a scale so where we have to get our the volumes, our weight distribution correct. So we end up with a universally consistent result in the resonate. So when we do our blending and densification, that's what we do in our process, the blending, excuse me, and densification of the plastic waste streams. When we do that, then we end up with a globally consistent end product in the form of resonate. So, so regardless of the feedstock we're getting, it's up to us to get the blending and densification right before the end product comes out. So you won't get a different product from week to week, depending on what waste stream we've had. Your product or the end product is the same, and we do the front end sorting to get that right.
My second question would be about the durability of this material. And you mentioned about microplastics are not an issue. But in terms of, is this kind of providing a same durable material as the normal aggregate, or kind of what sort of changes, I guess, you see in the material, and was that used like for a long-term kind of application, and what are the results there?
Yeah, so the changeability in the material is, to those who are working with it, the end user, is unknown. They don't feel or see a difference. In fact, the only changes that we've had from the end user is positive. They're happy to work with the lighter material, but the optics of it stay the same. The workability, so for concreters, the only comments have been that it's got a slightly better slurry for screeding, which they're happy about. But there's been no change to the use of the product as to a virgin aggregate. So it looks the same. It performs the same or better. The only difference, and when you pour it into someone's hand, that's when they notice the difference, because all of a sudden it's way lighter than what they expected it to be, because visually it would appear as just like normal rugged virgin aggregate. The durability of it is the same as we would expect from aggregate. So it doesn't feel or respond differently from any sort of normal virgin aggregates. So across the board, it feels, looks, and performs the same or better than the aggregate we've replaced.
Okay, thank you.
Thanks.
Sarina. Arthur.
Yeah, thanks, Shane. Look, I haven't got any specific questions. I think your approach in terms of its application is the right one. You start with the least hostile environments in terms of non-structural. You get the process down right. You get good quality control. You learn from that, and then you move on to those other issues. So I think that's a really good approach. And just for your information, Shane, Austroads, which is the peak organisation that represents all the road authorities across Australia and New Zealand, are currently working on Australian technical specifications, and concrete is one of those that's going to be tackled over the next couple of years and beyond. So there is an interest and an appetite to harmonise those concrete specifications. So again, you might be across it, but it would be good to familiarise yourself with what's happening in that space as well, Shane.
Yeah, thanks, Arthur. Absolutely. It's something we're finding that we have to keep up to date daily, because with innovation comes obviously need for review and sometimes modification. But yeah, we do try to keep up, but that's where we really appreciate this sort of forum and these sorts of organisations that can even keep us aware of what changes are taking place. I appreciate that, Arthur.
Thank you. And if I can just comment quickly, the use of recycled plastic aggregates in concrete and asphalt has already been done in Victoria. So the specs, don't ask me which ones, do permit for it. So our ecological reference guides, we've done some homework mapping the different standards and specifications, so you can actually look up where you can use different alternative aggregates in its place. So I encourage you to have a look at that on our website after this. With no other questions from the panel, thank you, Shane. That was fantastic to see, and I'd love to see homes one day made from all sorts of repurposed materials, beach cleanup, plastic waste included. There's a few questions for you, Shane, in the Q&A. If you want to hop in there and have a chat to the audience. And again, thank you for telling us about Resonate. So I'll be keen to see it when it's up and running in Victoria.
Thanks, Doi. Cheers.
Thank you. And up next, Chris, can I bring you to the podium and tell us what Replas is working on?
Hey, thanks, Doi. Thanks for the invitation, and good morning, everyone. My name is Chris Smith. I'm the Victorian and Southeast Queensland territory manager here at Replas. Thanks for taking some time this morning to hear from the presenters and ourselves at Replas about what we do and what we're working on. So I'll jump into, if anyone who doesn't know who we are already, I'll jump into a bit of an overview. So we're a recycled plastic manufacturer. We manufacture a number of products, and we've been operating for over 30 years, based out of Ballarat. It's where we started, and we're still manufacturing there today. In that time, we've manufactured over 750,000 bollards, 35,000 furniture items, and approximately 315,000 meters of enduro plank have been installed. And I'll go through those products soon. Over 50,000 tons of the most problematic plastic waste has been utilised by us from Australia, I should say. It's been utilised by us, and we make our products in Australia from Australian waste. It's something we're very big at Replas, is manufacturing from Australian waste to try and solve the problem onshore as much as we can, and then we can, once we've got that down pat, I suppose then we can look to expand outwards. If we jump onto the next slide, what I've done with this presentation is I've just collaborated a few inspiration shots, I guess, to show where and how our products have been used, because our products at the heart of them are quite simple. They're a fairly simple replacement for a lot of products that are currently used on many projects through all levels of government. So this first one here is an installation at Edith Vale Station recently with the station upgrade. You can see the black plastic sheeting. It's been CNC cut and fixed to the wall there to create an artistic installation, a bit of interest on the station there. Now, interestingly, the sheeting is actually a third-party product, so we don't manufacture the sheeting ourselves. We've long time been a distributor of it, and basically the face to the market for this product. We have had to temporarily suspend it recently, just because of a few production issues, but we hope to get that back under control. So if anyone has any questions about sheeting or anything like that, feel free to get in touch with us. I'm sure that'll be resumed quite shortly. The rest of the slides are all Ballarat product, made in Ballarat by us. This one's a good example of our profiles. So we make a number of just rectangular and square dimensions, for want of a better word, plastic lumber gets used a lot. But this is a creative use of it. And this was a level crossing removal in Cheltenham, where they've used the profiles as vertical battens around a substation. And not only have they utilised a single profile, they've used a number of the different dimensions to create a visual interest with the profiles jutting out from the fence railing, as well as the alternating colours to create the patterns there. This is not an overly uncommon use for our product, but I don't think it's very it's advertised a lot. So I thought it'd be an interesting one to show. On the next one is probably one of our main infrastructure examples, I guess. And this was done over 12 years ago, and it's still there outside the MCG. So it actually crosses over Jolimont Avenue, I believe. It's to Jolimont Station. It's quite a steep ramp up to that overpass, and it goes straight onto the grounds of the MCG. That was, like I said, that was done over 12 years ago. And interestingly, before we could do our enduro grip. So what they've done here, if you go and visit that installation today, you'll see there's a number of steel anti-slip or possibly aluminium powder-coated anti-slip plates that have been installed along the top of the decking. And that's due to the angle of the ramp being quite steep. And obviously at that stage, we couldn't create the anti-slip surface on top of our enduro plank. So they've come up with that solution for that installation. I was there probably a month ago, maybe 2 months ago, and I had a look at the enduro plank underneath those anti-slip plates. It still looks the same as the day it went in. It barely looks like it's worn at all. And that's one of the advantages of utilizing plastic in any of the forms that we've been speaking about today, is that it's such a durable, long-lasting material. And that's one reason why it's an issue in the environment, because it doesn't break down, it doesn't degrade. But then when you put it into a constructive use, you have the advantage of it not breaking down or degrading. So that's one of our main infrastructure installations in Victoria. On the next slide, if we hop across that, Doi, is quite a high-profile one in Queensland. So this overlooks a big gorge on a tourist attraction and a walking trail in northern Queensland. It's Barron Falls. And this is cantilevered over a cliff, I believe. And they've used our brown EnduroPlank there as part of the installation. And you'll find a lot of these installations are used. The EnduroPlank is used just due to its durability and its long-lasting aspects, because it doesn't need the maintenance. It doesn't have the high maintenance requirements. So for things where you have high traffic go through, low maintenance is obviously a beneficial aspect. So you don't have to continually go back and repair anything. And for this purpose, it's great. This is yeah, that's all right. Yeah, stay with that one. This is that was a crowning achievement at the time. So that was a new grandstand, or the new grandstand at the Flemington Racecourse. So all the seating was utilising recycled plastic. So all those battens on the seating are utilising recycled plastic. When you stand back from, or you stand over the other side of the racecourse and you look at it, it's quite stunning. Interestingly, one thing that one of our former directors, Mark Jacobson, used to say is, you know, you'd worry about it getting dirty because it's white, but because of the plastic, because of the fact that it's plastic and it's non-porous, all the people sitting on it and rubbing up against it all day with their suits somehow manages to clean it every time they sit on it and get up and shuffle along it. So yeah, so it looks stunning. It still looks great. I think that was about 4 years ago now. It was before COVID that was done. And yeah, it's a fantastic example of just a creative use. So that's not a seat that we make as standard. It's just something the Victorian Racing Commission, they wanted to use recycled plastic. So they found a use and a design that would make it work to their requirements. And everyone's a winner with that outcome. So on the next one, I think we move into more the range of products. So we've got two arms to the business. The one we're best known for is what we call our Civic range. So these are our furniture items, the decking, and our bollards. They're our three core product ranges. But then we also do our profiles, different signage, and we also do a few traffic control items like wheel stops, which is a growing market and really has a good chance to succeed and become, again, one of those core items, like the bollards. I've added down there just the color range that things can come in, but this is just a brief sort of summary of the products we do. In total, it's over 200 that we make, and that includes the next slide. So the next slide is what we are probably less known for, but also a big part of the business. And the reason for that is we run this side of the business through distributors. We don't actively sell direct to the market with these items. It's all done through distributors. But this is our civil range. So we manufacture a number of hydrants, marker posts, valve surrounds, wedge blocks, as you can see in the bottom corner there. There's cable stands. So there's a number of civil items that we manufacture that you wouldn't think is made of recycled plastic, but you've probably walked over many of them in estates and new estate builds and things, and not realised that you're walking over Victoria's waste. And that's pretty much it. With our products, and especially the civil products, you can see some of these designs are a bit elaborate in terms of their the shape of the product and the texture on the top. That just goes to the strength of what we're able to do with our injection molding, and it sort of leads on to the next point that I was going to raise. And that's that we'd love to work with you, and we invite all discussions on products. So whilst we've got a standard range of products that we make, we're also open to discussions on products that may be required in high volumes or custom situations that we can work with any of the big build projects on. So if there's something that has piqued your interest, or that you've got an idea from left field that may be useful, definitely come to us with the discussion, and we can investigate whether it's something we can assist on. And that's it.
Perfect timing, Chris. That's 10 minutes, so thank you. And great to see it used in such amazing locations. I think Arthur, since you've got your camera on first, fire away.
Okay, yeah, thanks, Chris. Again, very good presentation, and I think there's plenty of opportunities, I think, in that road furniture space where your product can be utilised. And again, I think that's where we should be concentrating on. Again, in the off-road space, there is a plastic noise walls specification that's being produced at the moment, and you're probably aware that a number of noise walls have been constructed out of recycled plastic. So that's, again, just for your information, you may have already looked at it, but that's just another avenue where every time there's a big build, there's likely to be noise walls installed as part of that. So no, what you've presented is very good. So well done.
Yeah, no, fantastic. I am aware of the recent one with the Ambiolock freeway. I was on that yesterday actually. I was having a look at the noise walls I was going past. Fantastic use for recycled plastic.
Fantastic. Thanks, Arthur. Irina.
Thanks, Chris. It's great to see very good examples of using of this type of products. My question was, I don't know if you mentioned that, but are we talking about 100% recycled plastic here, or what sort of percentage of recycled plastic? And in terms of controlling the material that goes in, how do you do that? How do you what sort of plastic material you use? Because that's probably one of the critical ones, to maintain.
Yep. So in terms of recycled content, we aim for a minimum of 85% recycled content in our products. More than likely we'll exceed that, but that's a minimum that we do with our products. All the way up to 98%. So there's always going to be at least 2% sort of UV stabilizer and master batch in there to assist with manufacture of the product and the color. In terms of controlling the plastic, we utilize three main plastics. So polypropylene, HDPE, and LDPE. And LDPE is commonly the soft plastics that's such a hot topic at the moment. With the control of the raw materials going in, we can control it to a point, but especially with the soft plastics, there's quite a lot of contaminants that go in there. So our products and our manufacturing process allows for some tolerances with the contamination of the raw material that goes in there, and especially with some of those civil products as well, because they're I guess less needed to be aesthetically pleasing as some of the street furniture stuff. So so we manufacture our batches with those three plastics. We try to keep contamination at a minimum, but as we would all know, working with recycled plastics, it's not entirely possible most of the time. So we have to allow for some tolerances.
Yeah, I assume you're doing the testing, to ensure that some of the basic parameters are achieved. My other question would be interesting to mention the signage that you're working on.
Yep.
Have you explored doing that for traffic signals, not traffic signals, traffic related signage, like on roads and all that? And what sort of durability we can get out of a plastic kind of signage? Are we talking the pole plus the actual sign, or what sort of I guess further development you can do there to utilize it on roads?
Yep. So in terms of road signage, I don't think we've looked into utilizing the material for that sort of purpose before. I don't know off the top of my head whether that would be possible with the material. It's something we'd have to, again, that's a conversation that's more than welcome, and we can investigate whether it's something that's possible. Durability of the signage we manufacture now, as with all of our products, we expect at least 40 years life expectancy out of it. We give a 10-year commercial warranty, but like I said, like the life expectancy, we would expect at least 40 years, if not more. And the other thing that I didn't mention in the presentation before is that when the products reach their end of life, they're circular, so we can take them back, we can recycle them, make another bollard or another sign or piece of decking out of it. So and that's something that we do currently practice with a few of the councils that bring things like vandalized product back or things like that. They'll take them back to us and we'll put them into the next mix, process them back and put them into the next mix. I hope that answers the question.
Yeah, no, definitely, and answer the other one that I was going to ask anyway. So
okay,
thanks for that.
No worries.
Thanks, Irina.
And
Kerry.
following on for that, Chris. Yeah, thanks for that, Chris. What sort of design life are we talking with those types of products?
Yep. So we were just speaking about that question with a different big build project that we're not consulting on, but working with. So the statement we've given, or the statement that we stick by, is at least 40 years. So we say 40 plus years with the product design life. I believe for the enduro plank, which is the decking, we've just given a statement to 50 years, which was requested, and we're more than happy to stand by that. But as just across the whole range, as a general design life, we would say the 40 years or more.
Yeah, wonderful. And with you saying you can go up to what is 98% recycled plastic content. Yep. With the planks, are they 90? Can you get those ones up to 98% as well?
The decking?
Yeah, the decking.
Possibly. To be honest, I'm not 100% certain of what the recipe of the decking is. It does more than the rest of our products. It has more of a controlled mix of plastics that go into it, just because it has to meet certain testing requirements being used for pedestrian bridges and walkways and things like that. So it always has to hold up within a tolerance of load bearing. So I don't know exactly what the top percentage of recycled content we can get into the decking is, but I can tell you it will be at least 85%.
All right, thanks a lot, Chris.
No
more questions from me.
Fantastic. Thank you, Chris, and always great to see such a comprehensive range coming from Replas. So people in the audience, please reach out to Chris if you want to order anything from Replas. Chris, I think that I'm assuming there's a few questions that have popped up in the Q&A, so feel free to jump in there and have a chat to the audience.
No worries. Thanks, Dory.
Cheers. And now to something a little bit different, I now invite Adrian from RCPA to talk about the EKOPipe. Adrian.
Yeah, thanks, Joy. Yeah, thanks everybody. Good morning. Appreciate everybody dialing in this morning, and I'd love to have the opportunity to present. Hope everybody's still keen and interested after going through the previous three, and I'm excited to talk about EKOPipe for RCPA. Just before we do, you'll notice the elephant there. This was a very clever thing come up with by our marketing people around addressing the elephant in the room. And so yeah, there is a connection. It also is intended to demonstrate the strength and durability of our product. So if you jump to the next slide, please, Doy, that'd be great. So I'll just talk. Normally, if I was doing this presentation in front of a group, I'd ask for a show of hands to see how many people have had the opportunity to see how concrete pipes are made these days, particularly in Melbourne. There's been a bit of a change. There used to be a process called spinning or spun pipes. That's pretty much being phased out around, certainly in Australia and around the world. And the most common method is what's called a vertical casting using a dry cast concrete. So just a couple of key points, and it is relevant because it's sort of one of the reasons why we've been able to develop this product. But we use a very special concrete, so it's very dry. It's either called a negative or zero slump concrete for those concrete technologists out there. It basically means you can add water to it and it still won't slump. It has a very low water cementitious ratio, which usually gives very good strengths. There's quite unique workability requirements. We want this concrete to pack into a mold and be able to be taken out of the mold immediately. So hence the zero slumping. And there's also basically no finishing requirements that are used there. So you'll see that's a picture of one of our guys dressing the top of a pipe that has literally come out of a mold like seconds before that. But that's about it. This process is also used for items such as concrete masonry blocks, concrete pits, and a range of other concrete products around the world. So yeah, next one, please, Toy. So just thought I'd touch on what we're talking about here. So it's RCPA has developed a product called EKOPipe, and we've named the technology that's behind that BX3. There is a reason for it, but I won't dive into that today. But we want to sort of flag, because people may not have heard of RCPA. So people sort of go, well, who's RCPA? Why have they been able to develop this concrete pipe? And it hasn't been one of the majors that's come up with this. Part of the reason is that dry cast pipes kind of suit this technology more than traditional concrete. Due to those workability and finishing requirements being different, that gives us the opportunity to introduce sort of processes or materials into the concrete mix that may not work in a flat work or a different kind of precast operation. The other part that is significantly different, and I'll talk a bit more about this in a couple of slides time, is that pipe's a fairly unique structure in that we actually test every batch of pipes that are made. There's a physical load test that's done usually multiple times per day. We test the concrete pipe itself to ensure that it's achieving its structural performance that's required. Yep, next one, please. So I'll talk a little bit about the development. So if people who've been around Victoria for a decade or more may recall, RCPA did actually introduce a product called ECP, which was a full geopolymer concrete pipe probably around 15 years ago, 12, 15 years ago. The problem with geopolymer and traditional alkali activated concrete, geopolymer concretes, is they're not very user-friendly, in short. They use some pretty aggressive materials. I know there's been developments and changes with powder systems nowadays, but they are significantly higher in alkalinity than standard concrete. They also require quite substantial curing control. They're very sensitive to curing, and those two elements combined pretty much meant that we weren't happy with that sort of technology. So what we did over the last 10 years is we went looking for a solution to a concrete pipe with low embodied carbon, rather than just focusing on eliminating Portland cement. So yeah, it was rather than reducing to zero, we looked at, okay, what can we do with binders? And we went through hundreds and hundreds of lab trials with our research partners to develop concrete that we believed had potential, particularly in the dry cast pipe manufacturing process. And that concrete uses a very high, doesn't eliminate Portland cement, but uses a very high replacement of Portland cement. So yeah, once we had the lab concrete working in the laboratory environment, we moved to plant trials, and it sort of exceeded our wildest expectations in terms of how well it worked. So we were pretty much then in a position where we needed to immediately move to do some equipment upgrades to get us into full-scale production. Now that's actually been a bit of a challenge with all the run out of COVID. A lot of our equipment comes in from overseas, so it's taken a bit longer than we would have liked, but we're now in a position to start scaling up into full production going forwards. Yeah. So in terms of what do the numbers tell? So we've done an initial, we're actually just waiting on the publication of an EPD for our standard concrete pipes, so that establishes the baseline numbers that you can see there, the tall charts there. So that's kilograms of CO2e per tonne of concrete that we produce in 3 of the plants that we've assessed. We've actually assessed all 5 of our factories around Australia for SRC EPDs. And we've done initial LCA modelling or life cycle assessment modelling for EKOPipe concrete. And what it shows, as you can see on the graphs there, is a pretty substantial reductions in concrete emissions for embodied carbon per tonne of concrete itself. Now that's achieved through, it's got greater than 80% reduction in Portland cement, and it depends on the location. There's a bit of variability there, and we are talking about the concrete that's actually being made in those plants. So these are not sort of abstract numbers, they're real numbers, but it does translate to a greater than 50% reduction in the CO2e for the concrete itself. Just before we move to the next slide, when we go to make the pipe, obviously we're using steel as reinforcing in the pipe. Now, while that steel there's a substantial percentage of that is recycled material, there is still a CO2e contribution from the steel that goes into the finished product. But what we land on is in the finished pipe, it does vary depending upon the pipe diameter and the pipe class. We land on around about a 45 to 50% reduction in CO2 for the actual pipe as produced. And comparing that to EPDs that are publicly available for other materials such as thermoplastics, that the EKOPipe CO2e values are actually lower than what you can achieve with a plastic pipe, which is really exciting. So in terms of what's the next steps, as I mentioned, we've got the EPD just awaiting final verification and publication through EPD Australasia. Hopefully that'll be done in the next couple of weeks. We will be developing an EPD for EKOPipe very soon. We just need to get a few more production runs under our belt, so to speak, and continue gathering some data to develop that EPD. And then future work is, we're not going to stop now. We've sort of had a really big win in terms of the cementitious content, but there's a lot of opportunities to look at alternative or recycled aggregates. I'm pretty interested to talk to Shane from Resonate in due course about that. One thing that doing an EPD or a life cycle assessment does do is it gives you a very good insight into your energy inputs through a manufacturing process, and that's a big contributor to the EPD or the CO2e for pipe manufacturing is the actual production process. So we look to optimize those energy inputs and introduce elements such as solar through our factories. And then optimize concrete mix designs, continuing to work on that. So we see this as being sort of like just the first step in a longer term road around developing our BX3 technology. Yep, next one, please. So I'll just touch on a couple of things related to the pipe itself. The two main things that we have to assess for our compliance with Australian standards is the strength of the product. Now, typically, concrete is measured by a compressive load test. And you'll see that sort of image of that on the left-hand side of the screen there. It's actually not required for making pipes. We don't have to do a compressive strength test of our concrete. What we do have to do is a load test, and the photo on the right there, so it shows an indicative setup for a load test of a concrete pipe. That being said, RCPA does do concrete compressive strength testing of our concrete as routine QC, and EKOPipe concrete is equally as good as a standard concrete pipe. We typically run strengths sort of in the sort of 60 MPa territory at 28 days, and we can easily achieve that with our EKOPipe concrete. In terms of proof load testing, it's equally as good, so there's no compromise there. And now you can go next, thanks. The other test is the durability, and durability is the big word, right? There's no point saving a bit of, whether it's using recycled material or saving a bit of carbon, if you have to replace that asset in less time than you would for the original one. Any gains you get there can be easily lost through extra maintenance or replacement. So durability is the key thing. And the key test that's used in the Australian standard for pipe manufacture is the water absorption test. It's akin to the VPV test for those concrete technologists in Vic, but slightly different. But what we do is we take the test sample from the wall of the pipe. So we don't use a cylinder that's cast in a mold. We actually take a sample from the pipe itself. And on the right of there is, the limit in the standard is 6% absorption. That's what we're allowed. We have to be below that. So our typical concrete ranges in the order of 4 to 5% testing. Our tests with EKOPipe concrete to date have been almost half. So we get absorptions of 2 to 3%. For those who are familiar with VPV numbers, we're generally in the single digits for VPV, around 8, 9%. So very good numbers for that. And to make sure that we are looking at the broader picture, not just focused on pipe concrete, we're also doing testing on chloride migration, confirming that the EKOPipe cementitious binder still functions as an alkali silica mitigation, and continuing to investigate other attributes there. So I just got, we'll stop on this slide, Doyle, won't go to the next one. So I just wanted to, in summary, and I think I'm pretty much bang on time. Yeah, just to say that, look, RCPA is very pleased to be able to introduce this sort of revolution in concrete pipes. We're certainly the first, to my knowledge, one of the first in the world to introduce a concrete pipe with a significant reduction in Portland cement usage. And we recognise that concrete continues to play a critical role in our built environment, just due to the fact that it has those unique and proven properties and have almost a guaranteed service life if correctly installed. So we're really pleased to be able to introduce EKOPipe with BX3. We have dropped those Portland cement use quite significantly. We've introduced a significant reduction in concrete. We haven't compromised on the strength or service life that you expected. Very keen to partner up with asset owners in Victoria and across Australia to get this new product in the ground. So yeah, thanks for the opportunity to present, and I'll welcome any questions.
Thanks, Adrian. Arthur, I think you may have pipped Kerry to the post.
Yeah, thanks, and thanks, Adrian. So no, certainly, it's another very good presentation. So they've been excellent today. And as you're probably aware, Adrian, in Victoria, supplementary cementitious materials, we've been able to replace GP cement since sort of the early 90s, and a number of our specifications that you're probably across allow the use of that product. So certainly from a Department of Transport and Planning point of view, certainly very supportive of these types of initiatives and innovations. So no, that's very good. Well done.
Yeah, thanks, Arthur. Yeah, we're really pleased. And actually, there's one thing I didn't mention is that the specs that relate to pipes in Victoria actually do specifically cover off EKOPipe. That's for those interested, section 701 and 730, I think, the relevant ones. And they do touch on the requirements for a geopolymer or very low cement concretes. So it's basically already ticked off.
Thanks, Arthur. Kerry.
Thanks, Adrian. No, it was a really good presentation. I had a couple of questions. So you've got the photo with the elephant. So what's the largest diameter pipes you create? So it looks like a 6-foot diameter pipe there, but what sort of diameter do you go up to?
As we stand today, we can make up to a 900 diameter pipe. We are waiting on, we've got 2 factories in Melbourne. So we've got one factory that's basically up and running with EKOPipe right now. So that'll range, it goes from 300 millimeter diameter to 900 millimeter diameter.
Okay.
Our other factory, we're just waiting on some fairly significant plant upgrades, but they should be completed within a few months, and that'll allow us to make up to 2100 diameter pipes with EKOPipe. We've load tested up to 900. So we've done the verification testing. We haven't done the big pipes yet, but I don't have any reason to think there'll be any problems with that.
That's good to know that's in the pipeline, for lack of a better pun. But just you're probably aware that we are facing a bit of an industry shortage right now in Victoria with concrete pipes in particular, for drainage, the bigger pipes. Hence why I was curious to know about that. Have you used these pipes in any rail applications? So like with stakeholders like MTM and V-Line, have you used it in under rail crossing in those type of applications and got their blessing to use it there?
If you talk about EKOPipe, no, it's too new. We haven't really used this in to be honest, any applications yet. We are really we switched on manufacturing pretty much late last year in Victoria. So we're building some stock, and we're effectively waiting for the right opportunity to introduce it. To say, could it be used? Absolutely. I mean, it meets the strength requirements that have been established in AS 4058, and they get installed according to 3725, and those standards have been around for decades. So there'd be no reason to think that there'd be any issue there. But that is one of the reasons we're continuing to do additional durability testing, though, just to sort of answer any questions that might sort of come from concrete technologists or durability specialists out that are looking at other concretes in addition to pipe concrete. So, but yeah, we wouldn't have any concerns at all using this in other applications such as rail.
Thanks for sharing that info, Adrian. It's been a good presentation, and we'll keep in touch.
Sure.
Thanks, Kerry. Irina.
Once again, thanks, Adrian. It's good to know what's available, and that more is coming on the market, because that's definitely the shortage of materials is an issue at the moment, especially for major projects. And my question is around first, I don't know if the pipe thicknesses are similar to any other kind of reinforced concrete pipes, or do you have like a smaller thickness, I guess, of pipe, and would that kind of impose on or require different type of handling and storage on site, and also kind of jointing of the pipes, and which then affects the durability or the kind of possibility for defects? That's one question. And the other one was, do you see any obstacles to kind of demonstrate compliance, I guess, of the product to the Vic Road standards and other specifications that are currently required?
Yeah, thanks, Irina. That's excellent questions. The first one's pretty simple. We use exactly the same molds and designs as we do for a standard Portland cement pipe. So if you were to see an EKOPipe, and I actually don't have any side-by-sides in the presentations yet, but I probably should. If you were to see an EKOPipe on its own, I doubt you would pick it as not being just a standard concrete pipe. They are a bit lighter in colour. So side by side with a Portland cement concrete pipe, you would see a difference. But aside from that, yeah, I'd be impressed if somebody could tell one from the other without having a reference. Compliance-wise, as I mentioned before to Kerry, there's already existing specs in Victoria for pipe manufacture, for manufacture and supply of drainage pipe, and they reference to another standard. It's actually a PIT standard, I believe, for use of geopolymer concretes. We conform to both without any issue right now. So there should be no technical reason why they can't be used. And I forgot to mention Kerry's question and your comment about supply. We are very aware, and I can say it's not a Victorian specific issue. Supply of RCPs around the country. Unfortunately, it stemmed back from one of our large manufacturing competitors shutting their operations on the East Coast fairly abruptly a couple of years ago, and the industry's been sort of reeling ever since. So we are working very hard to improve our outputs and do what we can. Unfortunately, EKOPipe isn't a new production line coming on. We still use the same production line, so we're not going to be seeing a massive change in the supply pressures. But all I can do is assure people that we're working, I think, 22 hours a day at the moment to try and make and supply pipes to the Victorian market and alleviate those pressures. I hope that answers your questions okay.
Oh, that's great. And one more additional question. In terms of the dry cast concrete mix, I don't know if there are any specifications within Victoria, but I was just wondering what sort of specification or standard you're using for the dry cast mix, I guess, concrete.
Well, we don't actually have, 4058, which is the Australian standard for pipe manufacture, does have some requirements in there around the materials that are used. But when it comes to the actual mix designs themselves, to my knowledge, there's not really any specification that exists in industry. And that's largely because we do both the strength and the durability testing on as cast items. So we're not relying upon the concrete. Well, basically, if we got our batching wrong, our pipes wouldn't pass the load tests, and they would be identified through our QC system before they even got into our stockyard. So it is a little bit different manufacturing of pipes. But that being said, the concrete that we make, whilst it's dry cast, that's really a function of we use the minimum amount of water that we need to basically hydrate the cement. We use relatively standard admixtures, so nothing particularly unusual in the industry. So we've gone through numerous audits with Vic Roads, TMR in Queensland over the years, and they certainly have no issue with the concrete processes that are currently in use. And EKOPipe, like it's still using the same cementitious materials. There's no sort of crazy new material that's coming out of left field there. They're materials that concrete technologists are comfortable with.
Yeah. Thanks, Phil.
No problem.
Thanks, Irina. Now, Adrian, with 2 minutes to go, I'm probably going to go to the audience and ask these questions live. So there's 5 questions that have come in.
Sure.
So first question is, Adrian, how does EKOPipe compare in CO2 to recycled plastic pipes?
Sure. Okay, I'll get through 5 in 2 minutes. We'll see. That's a really good question. I can't tell you because recycled plastic pipes, to my knowledge, haven't published any data on CO2e. So when they do, I'll be able to tell you. But the data that has been published is for the current profile wall thermoplastic pipes in Australia. And as soon as we get the LCA done for EKOPipe, we'll be putting those numbers out. But I can say I'm quite confident that in a cradle to gate scenario, EKOPipe will be better.
Thank you. Next question is from Felice Wong. Adrian, would the technology and application be able to extend to concrete sleepers?
I don't know. I don't think so, is the short answer, but I'm not familiar with the concrete sleeper market, so I can't really comment on that.
Not a problem. Adrian, is the technology across other products like culverts?
Not yet. Culverts do present a slightly different scenario, but we do have the opportunity to look at this in future. At the moment, we're not going down that path, but the answer is yes, potentially it can be applied to other products.
Right. Adrian, your website currently says only Victoria. Would this be available in Queensland as specifications with QR and TMR?
I can't talk to the spec side of things as yet. I'm actually based in Queensland. I work out of our Queensland office, and have a national role with RCPA, but we are currently, my office is surrounded by a construction zone because we're building a new batch plant, and that batch plant will be able to make EKOPipe concrete. So that's due for completion in a couple of months' time, and we'll be eagerly talking to TMR about this product in Queensland, probably around the middle of 2023, probably Q3 2023. Yes, we should have it in stock in Queensland, or available in Queensland, I should say.
Great. And Adrian, is there much of a price difference between EKOPipe and standard RC pipe, or perhaps one to take offline?
Look, very quickly, yes, there is. In the initial phases, we are putting a small premium on it, but our goal is to get basically to a parity with standard RC pipe in the not too distant future. But look, that's really one for the commercial teams to sort of discuss and review.
All right, man. Last question: what is the max pipe class produced?
In Australia, the max class that's in the standard is class 10. We haven't made any we've made just basically standard class 2 pipes in the testing side of things, but as I said before, given the concrete strength and performance, I wouldn't have any concerns making higher class pipes as needed. So yeah, potentially up to class 10s would be possible, but it'll all subject to you know, specific project requirements.
Fantastic. Thank you, Adrian. And thank you everyone for joining today's Innovation Showcase. Just last call out, I'm not sure how you found about today's event, but the easiest way is to just jump onto the join our Ecologic Knowledge Share and register with us, so you can get this event and other events that will be running throughout the year, such as our networking exchange, our conference, and you can also follow us on LinkedIn. So if you want to reach out to any of our suppliers or find out more, just reach out to us at ecologic@roadprojects.vig.gov.au. So without further ado, thank you everyone. From here on, if you've been inspired by today and been part of change, please reach out to us, because as you can see, these are great innovations, but they are complex pathways. So we'd be keen to work with you to bring this to life. Thank you for coming to the showcase.
Thanks, Dewey.
Thank you, Kerry.
Thanks all. Take care.
Thanks, everyone.